Today I'm going to be reviewing the Enjoybot 48 volt 65 amp hour lithium iron phosphate battery. This is the model that has Bluetooth and self-heating. I'm also going to tear it down and show you what's inside. Let's get started. But first, physical dimensions. 19.5 inches by 8.5 inches by 9.5 inches. And it weighs 55.5 pounds. Or about 25 kilograms. This battery can be monitored by Bluetooth app, so let me show you the Bluetooth app on my phone. On your phone in the app, if you search for Enjoybot, you won't be able to find anything. And in the user manual, it says specifically that you have to search for BAT BMS, and that's the app that you have to use. And this is the app. The app will show how much power the battery is putting out or receive. I have connected an incandescent light bulb, but this is an AC light bulb. But because this is a resistive load, it doesn't care whether or not it's AC or DC. You can see I've connected to the AC outlet here, and I can just turn it on. And because the current is too low, it does not show up on the app. So I've got to use something else. Let's try this again. This time I'm using a heating element, and it runs at 5 amp. This element is actually from an oven that runs on AC, but because it's a resistive load, it doesn't care whether or not it's AC or DC. I also connect the output to the light bulb to show you visually when the output is on or off. So this is the first page of the app, and we will show you the battery voltage, the output in amp, output in watts, and then the cell voltage, high and low. Down here is also show you the charge cycle. This battery was new, so I only have 2 cycles on this battery. Down here we have temperature of the battery. So currently it's at 15.7 degrees Celsius, and the BMS is 17 degrees Celsius. And down here we have voltage of each individual cell. This is a 48 volt, so it's a 16S battery pack. There are 16 cells in here, and it will show you voltage of individual cell. The battery cells are shown in different colors. Gray means it's lower voltage than the rest. Blue means higher voltage than the rest. And green means right in the middle. And if you want to see the difference between the highest voltage and the lowest voltage, you can come back here and it will show you the cell with the highest voltage is 3.292, lowest voltage 3.289, and the difference is only 0.003 volts between the high and the low. And therefore this battery is pretty much balanced. And on the very top, it will show you the state of charge of the battery. The output display on here is very accurate. You can see on my meter is teetering between 5.5 and 5.6 amp. Over here 5.64 amps, so that is very close. Let's go to the second page of the app, and this will let you control the input and output of the battery. Let's try the output first, which is the discharge switch. You see my light bulb is on, and the total output is 5.6 amp. If I click on it, see the output is now 0 and the light bulb is turned off. Click on it again, go back to 5.6, 5.7 amps, and the light bulb is turned back on. There's an auto balance here, so if we click on it, it will auto balance the battery, I guess. Down here we have the heating state, which is off, and if I click on it, nothing will happen. And that's because you need to connect a charger, and also the battery has to be cold enough for that to be activated. I've got my charger ready. Right now it's on standby. You can see the LED is alternating red and green. We got 0 input from my meter and also 0 input on the app. Let's go ahead and plug it in. Alright, we're charging at exactly 22 amp. This charger is advertised as a 22 amp charger, and look at that. It's charging at exactly 22 amps. Let's see what we got on the app here. 21.96 amp. That is very accurate. And the light on my charger is blinking red. That means it's charging. You can see the percentage. It went from 96 to now 97. Now let's take a close-up look at the app here. Input 21.96 amp. This is a positive number. That means the battery is receiving power. If this is a negative number, that means it's outputting power. So in this case, it is charging at almost 22 amp, 1197 watts. This number is very, very accurate. Let me show you again on my meter here. 21.96 amp, 22 amps. Very, very close. Now let's go to the second page and see if I can turn off the charger remotely with Bluetooth. So here you go. There we go. It turns off charging. The input current now is 0. Let me show you another cool thing about this app. This app is very universal and it can connect to other batteries as well. Click on the top here. Go back to this first page where it will show any batteries that have Bluetooth within range. So this is the Enjoybot battery we've been testing, but I have 2 other batteries that have Bluetooth and I can also connect to the other 2 batteries. So let's try this one here. Let's see if it's going to connect. There we go. This is a different battery and it's a 12 volt battery. You can see here 13.35 volt and the battery is 97%. And let me show you down here. So this battery only has 4 cells. That's because it's a 12 volt battery. And all other functions on this app are the same. So we go to this page, you can turn on and off charge and discharge functions. So if the original app on your battery doesn't work, you might want to try this app because it might just work. I have charged the battery to 100%. Let's go ahead and do a discharge test. And we're discharging at 3 amps. This capacity tester can only do about 150 watts. At 53 volts, 3 amp is about to max out the capacity of this tester. This battery is 65 amp hours, so at 3 amps, it's going to take about 22 hours. Right now we are 10 hours in, a little bit less than halfway in. Capacity 30.2 amp hour, voltage 52.3 volts. Recorded everything down here. It's going strong. And we are done. The BMS just shut down. The battery voltage 0.04 volts. So there's no more output coming out of the battery. And this is all of the data I have recorded. Let's see what we got. Total time is 22 hours 9 minutes. Capacity 66 amp hour. Here is all of the data I have collected. And here is the beautiful discharge curve. It stays relatively flat all the way near the ends. It's time to do some load test. I have a Trace SW4048. It's a 4000 watt, 48 volt inverter. This inverter is between 25 to 30 years old and it's built like a tank. Let's hook it up. First is the spark prevention program. To charge up the capacitor first, otherwise 48 volt is no joke. Alright, it should be charged by now. Let's see what we got. Whoa! 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 I've got a 1500 watt heater and a 1500 watt electric kettle connected, totaling about 3000 watts. On the AC side, it's about 30 amps. On the DC side, it's about 60 amps or so. The battery voltage right now, 53.4 volts, which is 100% full. This battery is rated at 120 amp continuous discharge. So this battery is plenty enough for this. Here we go. Turn on high. 30 amps. And let's turn on the electric kettle. 64 amps instantly. 63 amps right now. And the battery voltage 50.7 volts. It's been running for about 5 minutes now, and it runs just fine, nice and smooth, no problem at all. So let's turn it off. So there you go. At 3000 watts, this battery would take the load just fine, no hiccup, no problem at all. This battery is rated at 200 amp maximum continuous discharge. I want to push the battery to the limit with what I've got, that is. So I've got a mother of all stove, which I modified to have 22 elements in here, and it puts out about 110 amp at 50 volts. And I'm going to use my 1500 watts heater, which is connected to my 4000 watt inverter. And I also have a 1500 watt kettle. So the total output is going to be 110 plus 60, 170 total. I got 2 clamp meters. This clamp meter is on the stove. The other clamp meter is on the inverter. So those are the 2 outputs that I have connected to the battery. And let's turn on the stove first. 112 amps. Let's start the timer. Now we turn on the heater. Now we turn on the electric kettle. Let's see what we got. Battery voltage goes down to 47 volts. 106 amp on the stove. 72 amps on the inverter, which runs on the heater and the electric kettle. So total power is about 175 amps right now. 71 on here, 105 on here. Speed over 1 minute, still running. Let me show you how hot the electric stove is. 510 degrees Celsius. 530, 540, 550. And it maxes out my thermometer. Maxes out. That's it. And we're almost 2 minutes in. Still running just fine. Wow. Check out the elements. Getting so hot. It's red hot in there. Isn't that awesome? 8,000 watts. 5 minutes. Yep, and the water is boiling. All right, let's turn this off. I think that's enough for now. It's time for a teardown. Let's open up this battery and see what's inside. I got the top cover out, and I cracked the case in the process. It's glued together by silicone. There's not a lot of silicone, but there are 4 latches on the bottom case, and this locks onto the top case. So you really have to use a screwdriver and pry it out like that. And here is the inside of the case. The entire battery is completely encased inside a PVC heat shrink wrap. Ta-da! You got some silicone glue on the bottom. Here is the inside of the BMS. We've got 16 prismatic cells, and they are all connected in series. and they are all laser welded together with aluminum bus bar. All of the balance wire are in this bundle here, and there's bundle on the other side, and all the balance wire are screwed down to the aluminum bus bar. On the top we've got the main BMS, and there's a sticker on it. Quick search on Google, that's the part number, and it's a JBD smart BMS, maximum 200 amp discharge, and this is the BMS on JBD website. This is a popular BMS, and it's pretty well built. It's got a small heatsink on the top and a bigger aluminum heatsink on the bottom, and the wires that are being used to connect to the battery is size 8, and there are 2 of them. From the negative terminal of the main battery, it goes out to the BMS, and then from the BMS output to the main output on the top here. The positive terminal of the battery goes straight to the main terminal on the top, and the wires that are being used is also 2 size 8 wires together. The advantage of using a higher voltage battery like this 48 volt battery versus a 12 volt battery is that usually you don't use a lot of current because of a higher voltage. So you usually don't need to have thicker wire on a regular basis. On the top of the BMS, we got a balance connector, a Bluetooth connector, which goes out to a Bluetooth card on the side of the battery. And next to that, we have a temperature sensor connector, which has 2 pairs of wires coming out. And the 2 temperature sensor, they are glued on top of the cell by silicone. But both of them are glued to the same spots. Why? If you have 2 temperature sensors, they should be glued in different places. Why glue them in the same place? On the top of the cell, there is a QR code, and there's a part number. I tried a Google search for the part number, but I couldn't come up with anything. Next to the BMS, we have another circuit board, and this is the control for the heating pad. On this board, we got a red wire which comes from the main positive terminal of the battery, and then we got these 2 wires that output to the heating pad, which is on the bottom of the battery, and the output of this heating pad is controlled by this board. And here on the bottom of the battery, we've got a heating pad that takes up the space of the entire battery pack, and these are the 2 wires that goes to the heating pad. On the top of the board, we got 2 connectors for the temperature sensors. Here are the 2 sensors. The one on the bottom is just a regular sensor. The one on the top is different, and I tried to look up the part number, but I couldn't come up with anything. This battery has low temperature charging protection, so let's go ahead and test that. I got my charger here ready to connect to the battery, to charge the battery, and I'm going to use my duster to freeze the 2 sensors on the top here. Those are the sensors that are connected directly to the BMS. Let's first plug in the charger. Alright, we're charging and at 7 amps. Let's go ahead and freeze the 2 sensors, and it will stop charging when it's cold enough. There we go. Stop charging. 58.6 volts, and that's because it comes from my charger and not the battery. And see the light here, it's green, it's not charging. 0 amps. I'm going to use my finger to warm up the sensors. See if it's gonna resume charging. Oh, that is cold. This duster is cold. Yeah, it can go down to negative 30 or even 40 degrees Celsius. Very, very cold. There we go. It's warm enough and it resumes charging. It'll be charging at 7 amps. So it's working great. Let's try an overheat protection test. The BMS should turn off when the battery is hot enough. And I'm going to use my heat gun to heat up the sensors. and I use aluminum foil to wrap around the sensor so that my heat gun does not melt the sensor. I've got 2 light bulbs connected to the battery right now, and it's pulling about 1.1 amp at 52 volts. So that's about 55 to 60 watts. I'm going to use a temperature probe from my meter, and I'm going to stick right in here and wrap my temperature sensor from this meter with the BMS temperature sensor together, and that way I can measure accurately the temperature inside the whole thing. Here we go. It's rising rapidly in there. 85, 90 Celsius, 115, that's hot. 120 Celsius, which is 200 and, oh, it turns off. There we go. It turns off at around, I have to watch the video again. I just watched the video clip again, and the BMS actually turned off at 122 degrees Celsius, or about 251 degrees Fahrenheit. And it takes the BMS about 30 seconds later to turn back on automatically. So it worked great. Let's talk about the heating pad, which is on the bottom of the battery. When your battery is too cold, it will heat up and help warm up the battery so that the battery doesn't get damaged while it's charging. So the heating pad does not use power from the battery. It pulls power from the charger. And that means the charger needs to have enough power to power the heating pad, otherwise it won't turn on. And this is what it says clearly in the manual, that the recommended power of the charger has to be between 10 amp to 40 amp for that to work. I have tested it before with this charger, but it only puts out 7 amp, and therefore it did not turn on the heating pad. So let's go ahead and freeze the sensor. Don't seem to work. This time I'm going to use a different charger. This charger actually comes from Enjoybot, and it is a 10 amp charger, so hopefully it will work with this battery. I've got a multimeter here with a temperature function and a temperature probe, and I'm going to stick it right on the heating pad on the bottom so I can measure accurately the temperature of the heating pad. So right now it's 14.6 degrees Celsius. So here's my testing rig. The clamp meter on the left shows the current going from the charger to the battery. The clamp meter on the right shows the current going to the heating pad, and it only clamps on the heating pad wire. And the meter in the middle is the temperature of the heating pad. So right now it's about 13 degrees Celsius. Let's try this again. This time I'm gonna cool the 2 sensors that are connected to the main BMS, and also the other 2 sensors that are connected to the heating pad. Let's plug it in. And we're charging at 10 amps. I'm gonna cool the 2 sensors first. Alright, give it a moment, and then I'm gonna cool this sensor here. There we go. So 3 amps going to the battery, but we also have 3 amp going to the heating pad. So the energy doesn't go to the battery, but it goes to heating the heating pad. You can see the temperature is now rising. It is 21 degrees Celsius now, 22, 23, 24. So it will keep heating up until the sensors are warm enough. The heating pad right now is 45 degrees Celsius already. That is hot. And the power still goes from the charger at 3 amp, and it goes straight to the heating pad. 3.3 amps over here, 3.1. Oh, it goes back up to 10. That means the sensors are warmed up enough, so it cuts off power going to the heating pad. And now we're charging again at 10 amp. And over here on the heating pad, there's no power going to the heating pad. It's 0 on this side. And the heating pad temperature is reducing. You can see it was 45 degrees Celsius. Now it's going down to 41 and quickly. 40, 39. Yep, so it's working great. So there you have it, the Enjoybot 48 volt 65 amp hour battery. It's quite compact for a 48 volt, and it's an awesome battery. The build quality and the functionality is awesome. My next job is to put the battery back in here and glue the top cover back on with my magical organic homemade glue. But I'm not going to show you the glue strength test afterwards because the handle of this battery is on the base, so the top does not support any weight at all. That's all for now, folks. Thanks for watching, and I will see you in the next video.